I discovered something tonight while I was making some more attempts to make delegator cooperate. Uh, so what I decided to do is create a totally new location, do it from scratch from GitHub, and I discovered this that it required this tool called Binaryen. Um, so apparently the parity tech engineers have started using this in compiling ink. So it's a simple C API with single header used from JavaScript. It accepts input in WebAssembly-like form, but also accepts the control graph. It's fast in internal representation, uses compact data structures, optimized, and comes with a number of tools. When I tried to compile it, they talk about the advantage of its internal, I think IR stands for internal representation, but it's supposed to be fast and as close as possible for WebAssembly, to convert it to WebAssembly. And you can see they go through the internal representation, and I have to look a little bit more into WebAssembly to totally understand this. We haven't really gotten into that. But the whole point is it makes things more optimized. And the tool it requires is WASM opt. Loads WebAssembly and runs Binaryen internal representation passes on it. So that's the tool we need. So what I'm in the process of doing right now is I'm trying to build this. I also had to upgrade CMake, which is the make for the C code that this is written in. And what I'm going to do then is attempt to recompile ink and everything from scratch and see if then we can get delegated to build and add that to our chain. So, it's going to be interesting. One question that we need to look at is, okay, you're a developer, you want to write code for let's say, a substrate chain, Polkadot or similar chain. Is it, depending on your circumstances, it could be better to take existing Solidity code and run Solang on it like we did last night. Or it could be better to just use ink and write it in ink and do it that way. My thought would be, it really depends on your circumstance. If you've done a bunch of stuff for Ethereum, or you want to write small contracts that can run on either Ethereum or Substrate based chain, it probably makes sense to write them once in a Solidity and then use Solang to turn them into .contract files. If you are saying, no, this is going to be strictly for substrate-based chains and we want it as efficient as possible, it probably makes sense to use ink because it's going to be closer to where it has to run. Every time you put another layer between the code and that which it's running on, obviously there's more chance for incompatibilities. Could be slower. So there are disadvantages of that. But where something like Solang will really shine is if you're developing a smart contract that you need to run on multiple types of chains. So there's a place for everything. And if you really need something efficient and quick and small, you may want to just write it in Rust. Um, that's an option too. We haven't looked at that. I would think that ink would make it a little bit quicker, but that's always an option. And one thing to look at is what languages do you have to, how language agnostic are some of these chains. That's another thing you can look that is interesting. For example, we haven't looked at Python at all. Python is the most. I just reading something today. Python is one of the most popular. It is maybe the most popular language out there right now because it's used in everything from talking to something like this. Although I don't know if this particular board you can do Python on. You can certainly do it on the what's it called, the board that was put out by NVIDIA. I watched a whole series of on YouTube of wonderful gentlemen who is a brilliant retired engineer, has had an amazing career as an engineer, and I believe he's been working as a teacher, trying to use his talents that way. And he then on Saturday morning would come on and teach, and teach people on YouTube. And and I'm going to shout him out, Paul McWhorter. Check out his channel. Brilliant guy. Anyway, getting back to that's why Python is so popular, and can go from microprocess. There's even a version of Python that you can run on Arduinos and like types of boards, all the way up to people doing data science. I mean, the data scientists are either using R or they're using Python. So that is if there's a way to do this sort of work in Python, that would be great, because a lot of people already know Python, and it gets rid of the need to do another, to learn another language. But anyway, I'm going to continue trying to get this going, and I hope this has been helpful. I think this is very interesting. I think if you're going to be now looking at smart contracts on a substrate-based chain, you need to have a look at this Binaryen, which I'm probably pronouncing it wrong. There's probably some cool way of pronouncing it. And because you're going to be using it very likely as ink is now, or you're going to need to be aware of it as ink is now using it as part of their build process. So if you found this helpful, please give a like, please, and also if you want to see more, please subscribe, ring the bell, and I will speak to you next time.